Hello and welcome to this Vivado Quick Take on creating generated clock constraints. In this quick take, we will review the concept of generated clocks and give you some guidelines for creating them and reviewing them. What are generated clocks? Generated clocks are those clocks resulting from clock modifiers like MMCMs, PLLs, and dividers. The primary, or master clock rather, is created. Clock creation is covered in the quick take titled Creating Basic Clock Constraints. Please review that video if you need more information. The primary clock, known as the master clock, drives a clock modifier. The resulting clock is called a generated clock. The generated clock has some relationship to the primary clock. For example, it can be a multiple of the master clock, a divided version, or a phase-shifted version. Note that a generated clock may become the master clock for another generated clock. There are two types of generated clocks in Vivado. Clocks automatically derived by the tools and user-defined generated clocks. Let's take a look at each type. Vivado automatically derives generated clocks from primary clocks and creates them on output ports of the clock modifying blocks. This is useful for complex clock generation using MMCMs and PLLs. The propagation delay and modification factors like phase shift, multiplication, and division are automatically derived and included in the generated clock constraint. A general guideline is to create primary clocks, then allow Vivado to automatically derive the generated clocks. Only certain types of clock modifiers support automatic generation. Complex blocks like gigabit transceivers require you to manually create the generated clocks. This is accomplished using the create_generated_clock command, which we will cover shortly. Here's an example showing the clocks automatically generated by an MMCM. A 10 nanosecond clock is created at the input of an MMCM. Report_clock shows that Vivado automatically generates the three output clocks: the feedback clock, the output clock, and the clock multiplied by 2. Note the G in the attributes column. This indicates a generated clock. Here's an example of a user-defined generated clock. The primary clock drives a register divider to create a divide by 2 clock at the register output. Generated clocks for these types of user-defined circuits are not automatically inferred. You need to manually create the generated clock using the create_generated_clock command. First, the primary clock, termed clock 1, is created at the input port of CKP1 with a 4 nanosecond period. The create_generated_clock command uses the source of clock 1, which is the port CKP1. Then, this clock is divided by 2. The clock is created on the register output pin reg A/Q. As is the case with automatically generated clocks, it is recommended to use the report_clocks command after using the create_generated_clock command to review the generated clock and ensure their properties are correct, specifically with regard to the period, phase shift, and source information. So now you know what a generated clock is and how Vivado automatically creates them for clock modifying blocks. For those occasions when Vivado cannot generate clocks, use the create_generated_clock command. Always run report_clocks to verify generated clock correctness. This concludes the Vivado Quick Take on creating generated clocks. Thank you for watching, and as always, please check back at Xilinx.com for additional Vivado Quick Take videos.